Okay, so the endocrine system. Okay, the endocrine system. Now, the endocrine system is also it's a very complex system, just like the nervous system. Okay, it's one very complex system, similar to the nervous system, and it is made up of glands and organs. Okay, and with the glands and organs in the endocrine system, they are responsible for releasing hormones, or sometimes we call them chemical messengers. Okay, and these hormones travel through the bloodstream to go and supply internal body organs. Okay, so practically the endocrine system is made up of glands, and these glands, the glands, we call them endocrine glands. Okay, and these glands are going to produce hormones. They are going to produce and release hormones that will go and supply other various parts of the body for certain body activities to take place. Okay, now in anatomy, when we ask you the location, the general location of endocrine organs are distributed throughout your body. Okay, throughout your body, we have endocrine. We have some endocrine organs in your brain. We have some endocrine organs in your chest area or your trunk area. We have some endocrine organs in your pelvic area. We have endocrine organs that are distributed throughout your body. Okay, so in terms of the general location, unlike other systems that you can say, for example, if you take the central nervous system, it's at the central part of your body, within the skull and the vertebral column. Is that okay? But when we take endocrine organs, they are distributed throughout the body. So from your brain to your pelvic region, or from the brain to the pelvic region of your body. Now let's look at the common characteristics of endocrine organs. Endocrine organs are ductless. Say ductless.
Ductless.
Highly vascularized. Say highly vascularized.
Highly vascularized.
Target specific.
Target specific.
Cardiac specific.
Slower but long lasting.
Slower but
Lower
longer.
but longer lasting.
So you remember that nervous system is very fast. When it comes to nervous communication, it's very fast but short
Yes.
acting. When it comes to endocrine is slower. Let me give you an example. For example, let me give you an example of activity controlled by the endocrine system. Imagine that pregnancy. Let me take your mind. Imagine pregnancy was controlled by nervous system. Okay, and the other time I was teaching last year, but I told them I wish pregnancy was controlled by nervous system. What it means is that you get pregnant today, latest by afternoon, the child has grown. But you see, because pregnancy is controlled by the endocrine system, it's slow. Okay. So endocrine system is very, very slow. Okay, but when it produces something, it's long acting. Is that okay? It's longer lasting, but it's very slow in terms of its activity. That's endocrine system. So an activity like pregnancy will let you appreciate how the endocrine system works. Very, very slow. Okay, but long lasting. Okay, when they have to produce something, it's something that is long. And again, the highly vascularized means that, endocrine organs are organs that receive a lot of blood supply. If you want to think of any organ that receives a lot of blood supply, one of them is endocrine organs. For example, and that is why if you are going to do an endocrine surgery, for example, a patient is having a problem with the thyroid gland, thyroidectomy, they are going to do, if care is not taken, the patient can bleed and die because endocrine organs are highly vascularized. Okay, highly vascularized. Is that okay? Great. So when we say highly vascularized, meaning they are surrounded with a lot of blood vessels or blood capillaries, and usually rich blood capillaries. Okay. And the other word is target specific. That simply means that, every hormone has a target. Okay. So for example, if a hormone is responsible for, let's say, a hormone is responsible for metabolism, that hormone has a target in the body. So, for example, if a hormone is released by the hypothalamus, that hormone will not go and work on every organ in the body. It has a particular organ it will go and work on. So, endocrine system is target specific, meaning every endocrine organ or every endocrine hormone, okay, it has a particular organ or part of the body that it will target and go and influence its activity. That's why we see the endocrine system. One of the characteristics is that it is target specific, okay, and it is ductless. When we say something is ductless, meaning it secretes hormones directly into the bloodstream. Okay, so that means that, you see, for example, the thyroid gland, it produces hormone responsible for metabolism. But the hormone, we don't have a tube connecting to all parts of the body that the thyroid hormones will pass through. It will release the hormone into the blood. Then as the blood is circulating, it will go to where it's supposed to work. So endocrine glands are ductless. We don't have ducts connecting to them. Is that okay? Unlike the duct glands, we have duct glands. For example, if you go to the digestive system, we have duct glands. For example, like the salivary gland, it's a duct gland. Okay, it has a duct that it releases its secretions through. Okay, if you take the gallbladder, for example, it's also a duct organ. But the endocrine organs are ductless, meaning they produce their secretions and release them directly into the blood. They don't release them into ducts before they reach their target organs. They release their secretions into the blood. Then through the blood circulation, their secretions get to supply the organ. That's why we say endocrine organs are ductless organs. Okay, good. So let's look at, I have some concepts over here. So we have wireless communication. When you take endocrine system, how it works, it's like wireless communication. Let me give you an example. For example, if you take a communication system like MTN. If you take a communication system like MTN, now MTN, they have their signals in different regions, or they have their antennas, or maybe they are in different regions. Okay, now you can't be using MTN, then you get reception for someone using a Teltico. It doesn't work that way. Someone that you are using MTN, the reception you are going to get, you get reception for MTN alone. Okay, that simply means that simply means that. Don't worry, we've not started. What we are doing is true. Don't worry, we've not started anything yet. So, for example, if someone is using MTN. Okay, for MTN, you can't be using MTN and your signal you receive is from Vodafone. It doesn't work that way. Now, what I'm trying to explain is that if a hormone is supposed to target the heart, it's only the heart that the hormone can work on. That's what we are trying to talk about. So that simply means that every endocrine gland or hormone, it has a particular target. So, for example, if you take a hormone like insulin, if insulin is supposed to work on the liver, it only works on the liver. It's only the liver that the hormone will target. That's what we are trying to say. Okay, so and that is more like a wireless communication. Another example, for example, wireless communication. For example, if you are using a Wi-Fi, or if your school you have a Wi-Fi, now the Wi-Fi, which people are going to have the reception is probably someone who have been able to log into the Wi-Fi with the correct password. They would have the reception. It's not everyone passing by, unless probably the person have made the Wi-Fi unlimited, such that everybody is able to join. But endocrine system don't work like that. Endocrine system, they are like wireless communications. Is that okay? There is no cord. Okay, so I want you to appreciate how endocrine system works. There is no cord. Wireless communication. When we say wireless communication, those of you who have phones that sometimes you do hotspot, you see you don't connect a cord. So the network is on the other phone. You hotspot, then the other phone is getting it direct. That is how endocrine system works. So there is nothing like a tube that is connecting the one phone to the other. That's what we call wireless communication. That is how endocrine system works. Okay, so there is nothing like a tube that is connecting one gland to the other gland. So the gland at one side will release its hormone into the blood. Then through the blood, it will reach the other organ. So there is no tube connecting one gland to another organ for the organ to release the hormone for it to go and influence the other organ. It doesn't work that way in the endocrine system. That's why we say the endocrine system, it uses wireless communication. The wireless communication simply means that the hormones, they travel through the bloodstream. They do not travel through a tube or a duct to the organ. The hormone in endocrine system, they are released into the bloodstream. Then through the blood circulation, it gets to their target organs. That is why we are calling it wireless communication. Now, when it comes to the target specific, what that means is that, for example, if a hormone has been produced somewhere, and that hormone have to go and work on the heart, when the hormone gets to the liver, will it influence the liver? If a hormone is supposed to work on the heart, and let's say the hormone has been produced in the brain and is circulating in the blood, when that hormone gets to the liver, will it influence the liver?
No.
No, it can't influence the liver. Do you know why? It's because the liver is not having receptors for that hormone. So you see, sometimes some of you be in the house, you say, hey, today my reception is bad though. It's anatomy you are applying there. Your reception means that even though you are using MTN, but your reception is not good. Why is the reception not good? That is how endocrine system works. So endocrine system, for example, if you take maybe a hormone produced in the brain, which will go and work on the heart, what it means is that the heart has receptors for that hormone. Again, if I tell you that the hormone is produced in the brain, it will go and work on the liver. All it means is that the liver has receptors for that hormone. Another example, if a hormone is produced by, let's say, the brain, and it will go and work on your ovary, all it means is that your ovary has receptor for that hormone, or it has reception for that hormone. That's how it works. So the hormone will be released into the blood. It will be circulating throughout your body, but it will only work when it gets to the liver. It will only work when it gets to the ovary. Why? It's because it's the ovary alone that is having a receptor. So someone, if you are not careful, someone will think that, say, okay, for example, if a hormone is supposed to let your blood pressure go up, and it's released into the blood, let's say it has been released into the blood from your brain, when it gets to the liver, won't it influence the liver to do something else? No. That hormone will only be able to work when it gets to the heart. The reason is because the endocrine system is such that when a hormone is released, it's only a target organ that have receptors for the hormone. Okay, that's why we say the endocrine system is target specific. It has a target specific action, meaning even though hormones are released into the blood, but even though they are released in the blood, they will not influence all organs. They will only influence organs that have their receptors. So, for example, if MTN, their network signal is all over Ghana, but those who are able to work with their signal is those who are using MTN. If you are using Vodafone, you don't have receptor. Your reception for MTN network. Okay, so if you are also using MTN, you do not have reception for Vodafone network. That's how the endocrine system works. So if a hormone is being produced, it's only organs that have reception for that hormone who are able to be influenced or who are being influenced by that hormone. That's what we are talking about here. Okay, so the endocrine system, one, is a ductless system. When we say a ductless system, what it means is that the hormones produced by the endocrine system, they are always released into the bloodstream. Again, they are target specific. What that means is that when the hormones are being produced, the hormones will not influence all organs. They would only influence organs that have receptors for the hormones. If you don't understand these two things, endocrine system will be very difficult for you. So once you hear endocrine system, two things have to come into your mind: ductless gland or ductless system, and two, target specific. Ductless, what does it mean? What it means is that endocrine hormones, they are not released into a duct before they reach their target organ. They are released directly into the bloodstream, and through blood circulation, they reach their target organ. Target specific, what does it mean? What it means is that when a hormone is being released in the endocrine system, it won't influence every organ or structure in the body. It would only influence structures or organs that have receptors for that hormone. Is that clear?
Yes, sir.
So when we say ductless, what does it mean? When we say ductless, what does it mean?
It means that it's they,
Hormones are
they
released
secreted it
directly
directly
into
into
the
the
blood.
Come again.
Directly.
hormones
Hormones
are
are being
secreted
released
directly into the blood.
directly
Directly
into
into the
the blood.
bloodstream.
Means that the hormones are not released into a duct before they get to their target organ. They are rather released into the blood before they reach their target organ. Okay, when we say target specific, what does it mean?
It means that the hormones act on the cells, which is
Affects all
the man
organs. It
receptor.
affects the ones that has the receptors.
Again, come again.
It means that
Hormones
when
that
hormones
act
are
solely
released,
on
it doesn't
cells with
affect
matching
every organ.
receptors.
It only affects the
Good.
organs that have the
In
receptors.
fact, once you understand these two things, you are good to understand most of the concepts in endocrine system. Once you're able to understand that endocrine hormones, they are released into the blood and not into ducts. They are released into the blood, and through blood circulation, they reach their target organ. Then the other thing is that, so another thing is that, so for example, we can ask you a question like this for you to think. Like, for example, why is it that if a hormone is released, it doesn't influence all organs in the body? Why is it so? If a hormone is
Because
being produced and
Because
is being
that
circulated in the blood, it doesn't influence all organs in the body. Why is it so?
because
because it is
that
ductless.
receptors they have everywhere.
Because
Oh,
of the ductless.
take your time and answer, please. Someone.
It
Because
is only
it only
influenced by
influences the
organs that
organs that
has
have the
receptors for
receptors
that
to the hormone
specific
Good.
being
hormone.
released.
Excellent. Once you're able to understand that, you are good to understand endocrine concepts. Okay, so even though hormones are released into the blood, they would only go and influence organs that have their receptors. So it will be circulating. So for example, let's say a hormone has been released into the blood. Let's say it goes to pass through the heart. It will only influence the heart provided the heart has receptors for the hormone. It goes to the liver. It will only influence the liver provided the liver has receptors. So in endocrine system, if we tell you a certain organ is being influenced by a certain hormone, what it means is that that organ has receptors for the hormone. That's the meaning. Is that okay? Once you understand these two concepts, you are good to understand endocrine concepts. Now, so let's look at some images. So when we say something is endocrine, so you see how endocrine, you see this is a network, Wi-Fi network. Okay, so it's like Wi-Fi network. Okay, so let me show you something. So sometimes when you are making a call, let's assume we are making a call and you are not hearing me. We are making a call. Okay, when you are making a call, for example, if you are in Sotum making a call with someone at Medina, is there a tube connected to Medina and you are talking through? No,
No.
it's through the
No.
wireless. It's through the wireless.
Yeah.
That's how symbolical. That's how endocrine system is. So it's not direct. There is no duct connecting or no wire connecting. That's why we say it's more like a wireless system. Okay, it's more like a wireless system. But listen, if we are making a call and let's say you are talking but I'm not hearing you, it means that I'm having a poor reception. That's the meaning. That's what this diagram means. So you see I'm talking and we are making a call. I say, do you hear me? And look, if I say yes, what does it mean? If you say, do you hear me? And I say yes, in terms of networking, what does it mean?
It means you are hearing the
Good
person.
network.
No.
The
I
network
don't
is
blame you. I don't blame you because you are not a communicating student.
Wireless.
It means that if If I say, do you hear me? And you say yes, it means that your network, you have a good reception. That's the meaning.
Yes.
It means your
Mama,
reception is good. It means your network is good.
that's
But
what
if,
I said.
don't worry, but if I say, do you hear me? And you say no, what it means is that your signal is not hot. It's not good. Your reception is hot. It's not good. And that is what this diagram is trying to explain. So I found the diagram so interesting. So you see here, the person is having full network. So you see, sometimes you check your network, all the bar is full. It means you have good network. It means your receptors are active. Okay, your receptors are active. Then it means the communication will now go on. But if you can't hear, you say no, you can't hear, then it means there is a problem with your receptor. Or it could mean you don't have reception at all, or your reception is not good, or you are not having reception at all. This diagram over here, practically, this is how endocrine system works. So you see, do you hear me? That's the message. That's the hormone. So when the hormones are moving, they are moving. When they get to where their receptors are, organs that have their receptors, then quick, they work. They pick them up. Then the organs start working with the hormone. So it means a hormone can be circulating throughout the body, but it will only work on organs that have receptors for the hormone. That's how endocrine system practically works. Okay, let's look at
Sir,
few. Yes, please go ahead. Ask your question, please.
please, for the example you are saying, or
All
you are
right.
making, the person says that, can you hear me? And you say, no. If the person didn't hear, why would the person say yes?
No, 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 no.
Yeah.
I'm not looking at. Don't look at it in terms of. Don't look at it in terms of the response. We are looking at it in terms of the the other side, the person at the other side, whether they are hearing or not. Please
All
don't
right.
interpret it in a very complex way. So we are looking at it in terms of whether the person. So, for example, do you hear me? The yes here means the person is not hearing. Is that okay? To tell you symbolically that the person is not hearing the information, meaning that person is not having reception. Okay, not to say that you hear me, then the person responds yes, no, no. We are talking about whether the person hears the information. So, yes, to mean that the person hears the message. No, to mean the person does not hear the message. Not in terms of the person responding, that they hear the message. Don't try and weigh it. There's a simple diagram, so don't try and interpret it in a different way.
Okay.
All right, that is fine. So let's look at some few more concepts. When we say something is, we have what we call autocrine signaling. I'll explain that. We have something we call paracrine signaling, and we have another thing we call the endocrine signaling. Now, let me start with autocrine signaling. When we say autocrine signaling, okay, autocrine signal is like this. Autocrine signal is when a gland produces a hormone, and the hormone works on the gland itself. So, like for example, a gland, it produces a hormone, and the hormone influences the same gland has receptors for that same hormone it is producing. So look at this gland. So let's say this is a gland. You see, it's producing a hormone. That same gland is having receptors for its own hormone. It means the gland is being produced, and the gland work on the same organ itself. That kind of signaling or communicating, we call it autocrine signaling. What way can I explain? It's like you are talking to yourself. Okay, so we can have some organs in the body or some activities in the body where a particular organ produces a certain hormone, and the hormone, the same organ has receptors for that hormone. So a particular gland, it produces a hormone. That same organ has receptors for that same hormone. Instead, that kind of communicating, endocrine communicating, we call it autocrine signaling. So when we say autocrine signaling, it's a signaling where when a gland produces a hormone, that same gland has receptors for that same hormone. In physiology, we call it autocrine signaling. Now, when we say paracrine signaling simply means that a gland produces a hormone, and the hormone goes to influence another organ. So you see, we have a gland over here. We have gland A. You see, it's producing a hormone. But can you see receptors of the hormone on that same gland? Look at the hormone. Can you see receptors of the hormone on that same gland? No. You see, the receptors are on another gland or another cell. And that is what we call paracrine signaling. When we say paracrine, it simply means that a gland or a cell produces a hormone. And the hormone is another cell that has receptors for that hormone. Now look at autocrine. Let me go over autocrine again. So a cell is producing a hormone. That same cell is having receptors for that same hormone. Such a situation, we call it autocrine signaling. Now let's go to endocrine. Very interesting. Look at endocrine system. Once you understand this diagram, it will help you. There's a summary of endocrine system. So look at endocrine. You see, for endocrine, look at the cell here. The cell is producing a hormone, but the hormone is going to another organ. Another organ is having the receptor, but the difference is that the cell releases the hormone into the bloodstream. Look at the difference. Pay attention to the difference between the paracrine and then the endocrine. Look at the endocrine. You see the endocrine, there is a cell over here. The cell is releasing a hormone. The hormone is going to a target cell or another cell. But before the hormone goes, it doesn't go directly. It passes through the bloodstream before. That signaling is what we call endocrine signaling. This is how endocrine system works. Let's start from the endocrine signaling. With the endocrine signaling, look, a cell is releasing a hormone. That same cell has receptors for the hormone. So it means that the hormone that is being produced by the cell, the hormone works on the cell itself. That kind of signaling, we call it autocrine signaling. Now let's look at paracrine. You see, with paracrine signaling, a cell releases a hormone. Okay, a cell releases a hormone. The cell does not have receptors, so it's another cell having receptors for the hormone. But the difference here is that here, the hormone does not go through the bloodstream. It goes to the cell directly. That kind of secretion or signaling, we call it paracrine signaling. Now, let's come to endocrine signaling. A cell is releasing a hormone. The hormone is going to another cell. But before it goes there, it passes through the bloodstream. Let's go over it again. We have endocrine signaling. With endocrine signaling, we have a cell producing a hormone. The cell produces a hormone. That same cell has receptors on it to receive the hormone produced by itself. Such signaling, we call it autocrine signaling. Now let's look at another, the paracrine. The paracrine, you can see a cell. Look at the cell is producing a hormone. Okay, the hormone, the target for the hormone is on another cell. Okay, the target. But the difference here is that with paracrine, the hormone does not enter the bloodstream before it goes to the cell. It goes direct. That one, we call it the paracrine signaling. Now, endocrine signaling, the interesting one. Now, a cell is producing a hormone. It's just like the paracrine. It's producing a hormone. But before the hormone gets to the target cell that have the receptors, it has to pass through the bloodstream. This is a summary of the endocrine system. So with endocrine system, what makes endocrine is that, listen, the word endo means blood vessel, meaning a particular gland is producing a hormone. But before that hormone gets to the target, it has to enter the blood first. That is what we call endocrine system. Okay, so with endocrine system, a particular organ or gland produces a hormone. That hormone has a target cell. But before the hormone gets to the target cell, it has to enter the endo. It has to enter a blood vessel, or it has to go through the bloodstream before it gets to the target cell. That is what we call endocrine system, okay, or endocrine signaling. Okay, so understand these three concepts: the endocrine signaling, the paracrine signaling, and then the endocrine signaling. So the autocrine signaling, the paracrine signaling, and then the endocrine signaling. What is autocrine signaling? A cell is producing a hormone or secreting a hormone. the same cell has receptors for that hormone. Okay. Paracrine signaling. A cell is secreting a hormone. That cell do not have receptors for the hormone. It's an adjacent, it's another cell that has receptors for the hormone. But the hormone
Yes.
will not pass through the bloodstream before it gets to the cell. Endocrine signaling. A cell is secreting a hormone. It will go and target another cell. Remember, meaning another cell has receptors. But before the hormone gets to that cell, it has to enter the bloodstream. Who can summarize the three signaling? Yes, go ahead.
Okay. With the endocrine signaling, the cell releasing the hormone passes through a bloodstream before it gets to the targeted cell.
Okay.
The paracrine.
Okay.
And the cell releasing the hormones gets to a cell having the receptor, but it doesn't pass through any bloodstream. It goes there directly.
Okay, that is fine. Endocrine.
And is it autocrine? Yes, autocrine.
Okay,
And the
autocrine. Go ahead.
autocrine, the cell has a receptor. That cell now has the receptor, so it's like
It
it's
produces the
just
hormone, and the
it's
hormone works on its own
yes,
self.
its own self. Yes.
Excellent. Okay, can I have another person to also explain? Yes, let's have a second person to also tell us what these three signalings means. Yes, let's have another person, please.
Sir Josephine.
Okay, Josephine, go ahead.
Hello.
Yes, go ahead, Josephine. Yeah, listen. Oh, Franca.
Okay.
Is it Franca? Go ahead.
It's Franca.
The autocrine
Okay, so
signaling.
Let's listen to Franca first. When Franca finishes, then Josephine, you also talk. Let's listen to Franca first.
okay, so with the autocrine cell,
Okay.
a cell produces hormones, and that same cell has receptors for the hormones.
It's not cell, it's autocrine
And then the
signaling.
paracrine, and
Autocrine signaling.
the autocrine. Okay, so it's produced, and
So it is producing what? It is producing a hormone. And that same cell has receptor for the hormone. Okay, that is correct. Move on to the next.
okay, then the endocrine.
No, do the paracrine first. Do the paracrine.
Okay, so with the paracrine, it produces hormones, but it doesn't have receptors for that hormone.
Oh, say it well. Say it well.
It's okay. The paracrine signaling. It produces hormones, but it doesn't have receptors for that hormones. That hormones have influence on other
incomplete. Franca, organize it well. The paracrine. Let me say it, then you follow. With the paracrine, a cell produces a hormone, but it's another cell that have the receptors. You don't have to leave that out too. So apart from that, with the paracrine, when it secretes the hormone, it goes directly. It doesn't have to go through the bloodstream, before it gets to the target cell. So the paracrine again, a cell that produces a hormone or secretes a hormone, that cell does not have receptors for their hormone. It's another cell that has the receptors. But before the hormone gets to the other cell, it goes directly without passing through the bloodstream. That is what we call paracrine. So please come again with the paracrine.
Okay, so you said that with the paracrine cell, it produces hormones.
Okay, a cell produces a hormone. Okay.
a cell produces a hormone that does not
Okay.
have a receptor for that
That
hormone.
same cell does not have receptor for the
That
hormone.
same
Okay.
cell does not have a receptor for that hormone.
Okay.
Is that it?
Sure, you are not done. Oh. Please, you are not done. Sure, you have to
It
get it well.
produces the hormone to a different cell that has a receptor.
Good. You are now explaining, but even that you are still
And
not
and
complete.
and the hormone does not pass through any blood vessel.
That is excellent. Now that you've explained paracrine signaling, so please be very careful when you're explaining and to make it complete. Because if you say
Okay.
paracrine signaling is when a cell produces a hormone and it go and influence another cell, that is also endocrine. Unless you bring the difference that with paracrine, it won't pass through the bloodstream. Okay, yes, but endocrine, it will go through, because endocrine to that same cell will not have receptor. Endocrine to it will go to another, go and influence another. Okay, then I'll do the endocrine.
Okay, so the endocrine, a cell produces a hormone to have influence on other hormones, a other cell having a receptor through a blood vessel.
Okay, that is fine. Now, Josephine.
Say,
Okay, so Josephine, what is autocrine signaling?
the autocrine signaling is when a cell produces a hormone, but the
Okay,
same cell is having the receptors for that particular hormone produced.
okay,
Yes.
okay,
And then
okay. But let me ask you this question. Let's discuss this question. Okay, what if there is an endocrine cell, and the cell secretes a hormone? That same cell has receptors, but the hormone goes to the blood before it comes to that same cell. How will you call that?
the
Endocrine.
That is endocrine. Yes, that is also endocrine.
endocrine.
Okay. So a particular cell, that cell has receptors. That same cell has receptors for the hormone it produces. But when it produces the hormone, it goes to the blood. So the principle with endocrine is that the moment a hormone has to enter the blood before it reaches the target cell, automatically it's endocrine signaling. Once you understand this, you understand endocrine system. Let's take say be a Josephine, oh yeah, gland. Now who produce hormone? Hormone now who produce, the hormone works on yourself. That hormone works on yourself. Provided you produce the hormone and the hormone enters the blood before it comes back to you, it's endocrine signaling. But let's say you produce a hormone. Josephine produces a hormone. That same hormone, you have receptors for the hormone. But when you produce, it doesn't go to the blood before it comes to you. You produce and it works on you directly without going to the blood. That is autocrine. But the moment endocrine comes in, what it means is that the hormone has to enter the blood before it reaches the target organ. We don't care whether the target organ is the gland itself. We don't care. The principle we are looking at is that with endocrine, the hormone has to enter the blood before it goes to wherever it is going. So keep the principle in your mind. So when we say endocrine system, the principle is that whether the hormone, the organ producing the hormone, even if the hormone will work on it, once it enters the blood before it comes and work automatically, that is what we mean by endocrine signaling. But when we say autocrine signaling, that one, the gland produces it and it works directly on itself. It's not going to enter the blood. When we say paracrine, another gland or a cell is producing it, but the target cell is at another place. But here, with the paracrine, the hormone will not pass through the bloodstream before it gets to the target cell. When we say endocrine signaling, a cell A is producing a hormone. The hormone is going to cell B. It's cell B that has the target, the receptors. But before the hormone gets to cell B, it has to pass through the bloodstream. That's the difference. Okay, so I hope you've all gotten the autocrine signaling, paracrine
Yes,
signaling,
sir.
and then endocrine signaling. Okay, these
Yes,
are things,
sir.
and usually we ask questions on this in MCQ. Okay,
All
so for
right.
example, the type of signaling whereby a cell produces a hormone, and the hormone has its receptors on another cell. The hormone influences the cell without directly or without having to enter the bloodstream. What type of signaling is this?
Paracrine.
This is paracrine signaling. Okay, but listen to this one. A cell produces a hormone.
Mm-hmm.
The same cell has targets for the hormone. But before the hormone reaches or influences the cell, it enters the bloodstream first. What type of signaling? Is it autocrine or endocrine?
Endocrine.
That is
Endocrine.
endocrine. So keep it in your mind.
Yes,
And that
because
sometimes
of the
in physiology,
flash.
examiners can trick you. The moment the hormone enters the blood, before it goes to influence the organ, whether it is the same gland that produced the organ, we are not interested in that. With endocrine system, our principle is that hormone, no, as a remogenuma and sana could do. That is what we call endocrine. Once you understand this concept, you've got an endocrine system. So with endocrine system, the principle is that before the hormone goes to reach, it has to use the blood vessel or the blood. So for example, let's do this example. A hormone produces, a gland or a cell produces or secretes a hormone. The hormone passes through the bloodstream before it reaches another target organ. What type of signaling is this?
Endocrine signaling.
Okay. Endocrine signaling. Okay. What type of signaling does the type of signaling where a target cell produces a hormone or secretes a hormone, and the hormone directly influences that same cell without entering the bloodstream? What type of signal?
autocrine.
Autocrine. Autocrine signaling. Okay. What type of signaling is used in the endocrine system?
Mm-hmm.
Which type of the signaling is used in the endocrine system? Among the three, which of them is used in the endocrine system? The third one, the endocrine signaling.
Correct.
So, yes, and that is why this diagram is there, to let you understand how the endocrine system works. So, see, this is how the endocrine system works. This is how the endocrine system. Once you understand these diagrams, in fact, you are good to understand or comprehend the endocrine system. Okay, so that's how the principle with endocrine system is that, so in endocrine, once you come to endocrine system, all that you are looking is that the hormone that has been produced, it has to enter the blood before it goes to where it is going. That is the meaning of endocrine system. So the hormone, if the hormone will not enter the blood before it will go and reach target organ, it's not endocrine system.
No.
Every gland that will produce a certain hormone, and that hormone will not pass through the blood before it go and influence the organ it has to influence. It's not endocrine system. So, and this is the basic principle underlying endocrine system, the endocrine signaling. Okay, so it means that even if the hormone, so let's assume I am a gland, I produce a hormone. That same hormone works on me, meaning I have receptor for that same hormone. Now, I will only become an endocrine gland. It doesn't matter that the hormone I'm producing, it works on me, so I have to produce it directly to myself. That is not endocrine.
No.
For it to become endocrine, that hormone, by all means, have to go to the blood before it comes back, even if it's that same organ that will use the hormone. So the principle with endocrine system is that when the hormone is being secreted, it has to enter the blood before it goes to wherever it is going. Even if it is targeting, the target is the same cell that produced the hormone. So in endocrine system, the signal transmission we use there is what? The endocrine signaling. The endocrine signaling. So let's look at this diagram over here. So you see this diagram, this is an endocrine cell. Why is it an endocrine cell? Who can explain? Look at this diagram, the diagram B. Why is it an endocrine cell? Explain. Why is this an endocrine cell? Look at the diagram B. Why is this
Say,
an endocrine? Yes.
because it passes through a blood vessel before it gets to the targeted cell.
That is 100% correct. It means we are concentrating.
Good, good.
So you
Yes,
see, we
100%.
have an endocrine cell, and the cell the hormone is having, the receptor for that hormone that is being produced is on another cell. But when it released the secretion didn't go directly to the cell. It entered the bloodstream first, and this is
First.
what makes endocrine system. Into anytime you hear endocrine system, the first thing that should come into your mind is that there is a certain cell going to produce a certain hormone, and that hormone have to enter the bloodstream before it go and influence another cell.
Yes.
That is endocrine
Thank
system. So
Mm-hmm.
if a cell produces a hormone, and if the hormone even works on itself, before you can call that cell endocrine cell, if the hormone even works on itself, hormone is what the chromogenome and son about on one inch.
Uh-huh.
Do you get it? You will not say it's because the cell is producing the hormone for it, or it can produce and give it to itself direct. No. Then that cell, you will not call it endocrine cell. For a cell to be endocrine, when it produces its hormone, it has to go to the blood before it goes to where it is going. Even if it is the same cell that it will work on, it has to go to the blood before it comes back. That is endocrine system. But look at this cell. Look at the nervous. You see the nervous system, the axon also secretes some chemicals. You see that one, when it secretes, it doesn't go through the blood. That is direct. That is an example of a paracrine. Okay,
Yes.
that's an example of a paracrine signaling.
You
So you see the nervous system, the axonal terminals, okay, or the axon terminals, when they secrete their neurotransmitters, the neurotransmitters goes directly to the target cells. Okay, and that is what we call the paracrine signaling. So an example of a paracrine signaling is that of the nervous transmissions. Is that okay? That is an example of a paracrine signaling. Okay, great. So understand these three concepts: autocrine signaling, and usually in an endocrine system MCQ, you are going to see these three concepts there: the autocrine signaling, the paracrine signaling, and then the endocrine signaling. No, understand it. Is that okay? Understand it. Okay, what we can do is that we can give you the diagrams in exams. Here, we will not let you draw, but we can examine you on it by giving you the diagrams, and you will write. So when you see this diagram, so you see this cell, you see the same cell is producing a hormone and it's having receptors, but you see it's not going to the bloodstream before it comes to the cell. So here, autocrine. Okay, this cell, so if you see a diagram, something like this is paracrine. Is that okay? Good. But when you see a diagram like this, once you see blood vessel inside, automatic, then you write paracrine signaling. Sorry, endocrine signaling. Once you see the blood vessel like this, automatically then you write endocrine signaling.
Endocrine. Yeah.
Excellent. All right. So once you've understood this, so if someone asks you to define endocrine system in your own words, a simple definition you can say is that with endocrine system, a particular hormone has to secrete, a particular cell has to secrete a hormone. But to make it endocrine, the hormone by all means have to enter the blood before it reach a target. That is the meaning of endocrine system. That's what we call endocrine system. Okay, and the word endo you are seeing there means the blood vessel. That endo you are seeing, the endocrine. The endo you are seeing there, the crine is about the signal. The endo you are seeing there is about the blood vessel. So meaning a gland produces a hormone. Before the hormone reaches the target organ, or even it could be that the target is even the same gland. But the principle is that it has to enter the blood vessel first before it reaches the target. That is what we call endocrine system. Okay, great. So we have some keywords, some terms that you can learn over here. So we have the endocrine glands. When we say an endocrine gland, a gland that secretes a hormone, and the hormone is released into the blood. So from today, if someone asks you what is an endocrine gland simply means a gland that produces a hormone. That hormone mandatorily have to enter the blood before it reaches a target. That is what we call an endocrine gland. Okay, we have an exocrine gland. Exocrine gland, like the salivary gland, they release their secretions directly into a duct. That is an exocrine gland. Okay, and we say receptors. Receptors are more like, so you see this hormone. Look at this cell. You see the cell, we have receptors on it. Can you see the receptors? Look at these ones. They are the receptors. Can you see the blue ones? Can you see them?
Yes.
Can you see them? These blue ones. Can you
Yes,
see?
sir.
But look at this. Look at the paracrine. Can you see? Look at the paracrine. You see the receptor? The receptors are on the surface of another cell. Look at it. You see the receptors are on the surface of another cell. Now, these receptors in the body, that's how it is. So the receptors, they are made up of proteins. The receptors for the hormones, they are made up of proteins. So when we say receptors, they are protein molecules on the surface of target cells. Okay, so when we say a receptor, so if I ask you what is a receptor, it's a protein molecule on the surface of a target cell for a hormone or for a gland. Okay, so here too we have a receptor. The receptors are made up of protein. In fact, even if we ask you what is a receptor, you say they are made up of proteins that are on the surface of cells. It's correct. So receptors, they are made up of proteins and they are usually on the surface of the target cells. Okay, good. Then we have the negative feedback and positive feedback. You did this in Anatomy 1. What is negative feedback? And we say negative feedback, what does it mean? Then we say negative feedback mechanism, positive feedback mechanism. What's the meaning of negative feedback mechanism?
The mechanism change is reversed to maintain balance.
Oh, you have an idea, but incomplete. Yeah, but you have an idea. The response shows you have an idea. When we say negative feedback, what does it mean?
Sir, can I also say that maybe
I give example. I usually prefer examples. Give example of a negative feedback mechanism.
paracrine?
Hey, this example there. It's not, paragraph is not an example of negative feedback. Give another example. Oh, negative feedback. Negative feedback is a homeostatic mechanism. When we say negative feedback, it's like a correctional mechanism. So a negative feedback, when we say a negative feedback, so for example, you see, if your blood pressure is high, okay, when your body have to correct it, okay, the response that will come and negate what is happening, will come and reverse what is happening. Another example, if your body temperature is very high, what response will you be expecting? If your body temperature is very high, what response will you be expecting? What will you expect your body to do? If your body temperature is very high, what response will you expect your body to do?
It should go down.
Good.
Like
so you see, the initial stimulus was high. The reverse action should be what? Should be negative. Another example, if your blood pressure is very high, what response will you expect your body to give? Your blood pressure is very high.
It should calm down.
It should calm down. So you see, in negative feedback, the response stimulus should be a reverse of what was happening. So for example, if what was happening was, let's say, high, the response should make it low. If what was happening was low, the response in your body should make it high. That is what we call negative feedback. So in negative feedback mechanism, the response stimulus should be a reverse of the initial situation. But when we say positive feedback, the response should be an enhancement. So for example, if a woman is in labor and the uterus is contracting, will you expect your body to reduce the contraction? No. You expect the body to enhance the contraction. That is what we call the positive feedback. So in positive feedback, this is a mechanism where the body will rather enhance the activity that was initially going on. For example, during the process of ejaculation, You not say because the person is ejaculating that it should reduce. You want it to be negated. No. You rather want a response that will enhance the activity that is already going on. Okay, and that is what we call, another example is when you are breastfeeding. When you are breastfeeding and the baby is suckling the breast and breast milk is coming, you not say the response you want is that for the breast milk to stop producing. The response will be to enhance what is already going on. So in a situation where something is going on in the body, and the response we are expecting is to come and reinforce or enhance what is already going on, then we are talking about positive feedback mechanism. But when we say negative feedback, if an activity is going on and another activity is coming to occur, but we expect it to reverse what is already going on, that is what we call negative feedback mechanism. Is that okay? Yes. And this is how these mechanisms is also very important for you to appreciate the endocrine system. Okay. It's also very important for you to appreciate the endocrine system. Okay. All right. Then, and I think we've done the autocrine signaling, we've done the paracrine signaling, and we've done the endocrine signaling. Okay. We will end with this slide. We will end with this slide for today. Now, these are the major endocrine organs we have in the body. These are the major endocrine organs. The hypothalamus, the pituitary gland, the pineal gland, the thyroid gland, the parathyroid glands, the adrenal glands, the pancreas, the ovaries, the testes, and the thymus. Say this after me. Say hypothalamus.
Hypothalamus.
Gland. Pituitary gland.
Pituitary gland.
Pineal gland. Pineal gland.
Pineal gland.
Thyroid gland.
Thyroid gland.
Gland.
Parathyroid gland.
Adrenal gland.
Pancreas.
Hey, different schools, so share. Someone is saying pancreas, pancreas. Everyone is saying their own.
Yep.
Ovaries. Testes. And then thymus. For the last time, hypothalamus.
Pituitary gland.
Pineal gland.
Gland.
Thyroid gland.
Parathyroid gland. Adrenal gland.
Pancreas. Ovaries. Testes. So these are the major endocrine glands. Okay, these are the major endocrine glands. And we have so when we say endocrine system, these are the major glands that we'll be talking about. But we have other organs in the body. They are not major endocrine glands, but they also produce hormones. Okay, they also produce hormones. So for example, if you see, for example, the skin produces some hormones. The liver also produces some hormones. The heart also produces some hormones. The kidney produces some hormones. Adipose tissue produces some hormones. Placenta produces some hormones. The JIT produces some hormones. So these ones, they are not major endocrine glands. Is that okay? They are not major endocrine glands. When we say the major endocrine glands, these are the major endocrine glands. Okay? So from tomorrow, we will start looking at the major endocrine glands, like the hypothalamus, the pituitary gland, the pineal gland, the thyroid gland, the parathyroid gland. We will start looking at all these glands. We will look at the hormones they produce and the functions of these hormones.
The hypothalamus is located in the brain.
So you can start reading in advance. You can start reading in advance so that tomorrow when we come, it will be an active it will be an active
All
class.
right.
Okay.
I wish you guys all the best. Bye bye.
Bye.
Um,
Bye.